particularly, it's interesting to notice that about a quarter of a century these days ago, we were approving the MPEG-2 standards. So the MPEG-2 standard is kind of history nowadays. But, you know, it's remarkable because it was about developing an infrastructure starting from something that is very small, almost invisible, and that is the compression factor. Nowadays, you consume, every person in this room consumes probably tens of videos every day, from either from your television set or from your handset. And so this pervasive presence of a video has become possible because 25 years ago we developed a standard, then we developed more. But you know, once you do the first, the other ones are easier. So what I would like to do something like, I think that in Chinese you say, 11月19日. I'm not going to talk too much about Wengu, but I'll try to talk more about Chexin. So the title of my speech is Artificial Intelligence Everywhere. And I start from a couple of examples that again are inspired by the idea of creating an infrastructure. So today, adaptive bitrate streaming is everywhere. MPEG has developed a couple of standards for adaptive bitrate streaming. And if you really want to deploy adaptive streaming, you have to put something intelligent in the network. So you can think of having a neural network for adaptive bitrate. And the important thing is that once you deploy this component, that is not expected to be there forever. So one explicit feature of intelligence is that what looks like intelligence today may look dull tomorrow unless it continuously innovates. Another case is public security. You can, again, you can use surveillance, just like capturing video and transmitting video, but it's probably more interesting if you add some intelligence in the cameras themselves. And here again, you have the same problem. You can have something that is intelligent today, but something tomorrow that will be completely out of date. So let me take another case. I know that Google is not particularly popular in this country, but of course it's a very important company and we have to learn from what they do. So let's take this sentence from this executive at Google. He says that if every Android user in the world used about 3 minutes of voice recognition time per day, Google would need twice as much computing power to handle all the requests. So this means that the largest computing infrastructure of the world would have to double the size of its infrastructure. Let me take another case. So here we are talking of a Google Assistant. They say, today we've reached a new milestone. Building upon advancement in recurrent neural networks, we developed completely new speech recognition and language understanding models, bringing 100 gigabytes of models in the cloud down to less than half a gigabyte. With these new models, the AI that powers the assistant can now run locally on your phone. This breakthrough enabled us to create a next-generation assistant that processes speech on device at nearly zero latency, with a transcription that happens in real time, even when you have no network connection. So it's kind of rediscovering that having the intelligence on your device instead of somewhere in the network is probably a good idea. It's not for all cases, but it is a good idea. And here we have another comment about the fact that the neural networks are very, very large and getting larger at every release. So these are some examples of the size of neural networks. So we are talking of 250, 500, 1.8 thousand gigabytes for commonly used neural networks. So the point is, why should we keep on adding intelligence in the center, and so in the data centers, wherever, and why shouldn't we distribute the intelligence in where it is used and where it is needed? So these are the examples. So then let me analyze with you a system view of the new trend. Again, I am referring to digital television 25 years ago. So we had a system view, but eventually we discovered that there was a little thing that could enable the entire system. So the first observation is that more systems embed and will embed AI components. There are already today, and there will be more, billions of devices and applications that are powered by those AI components. AI components become more and more sophisticated, and as the AI tools develop, the AI components can and will be updated more frequently. So it's what I said before. You have intelligence today, but the intelligence of today, tomorrow, needs to be updated. But if all the intelligence is distributed everywhere, you have the problem of distributing the intelligence. Therefore, to deploy new releases of AI component to millions or billions of installations, we need a generic tool to reduce the size of the neural network, and that is what the picture in this slide shows. So, of course, you know very well about neural networks. Others have talked about that. In particular, in MPEG, we are handling multimedia standards, and therefore we are interested in artificial neural networks that can be used for visual or audio content recognition and classification, speech processing, image and video coding. This is a very exciting new area. People are discovering that they can convert many of the pieces that exist in video codecs today with neural network technology. Some are even thinking of having a single approach to neural network-based to video coding. And therefore, deep learning uses very large neural networks, and here we have the issue when we compress the neural networks, so how much of the compression can happen in the first layers and how much can happen in the deeper layers. How they are used, of course, they used, you train a neural network, then you can apply inference using train the network for prediction. So neural network needs all the parameters. On the other hand, not all parameters are really important. So you can work on that. And then when you have a neural network in a device, the device can be very often be resource constrained. So let me talk about the requirements that have guided the work that we are conducting in the MPEG group about the neural network compression. So the first requirement is that there should be a lossless mode. Some people everybody's interested in compression, but some people don't want the network to be affected even minimally in its performance. On the other hand, there are people who are really interested in having a small size of the neural network, and if there is some loss in performance, too bad. Therefore, there should also be a lossy mode. Another requirement is that the compressed neural network should be scalable, in the sense that if you have only a portion of the information, you still have a usable neural network. Another, which is similar to the previous one, is incremental updates, in the sense that you can download a neural network and you can start using the neural network while the downloading is completed. Error resilience is something that means that you have a compressed neural network, you transmit that neural network, there is an error. That doesn't mean that you have lost everything. You have lost something, but not everything. And then I have more requirements. We have incremental updates. You can receive updates from many sources. It can be robust to interference, because it should be possible to detect that the compressed neural network has been tampered with. You can decompress the network with limited resources. You can compress without accessing the original training data, and you can have inference using compressed neural networks. So we are developing this standard, and we are leveraging our know-how and technology in compression in various types of data. So this is the timeline. We started 2 years ago, and we plan to finish in 1.5 years. So it will be a 3.5 year development. So this is the neural network test model. There are many researchers working on it, many from China as well. And we are playing with other entities, like SC42, ITUT, of course, Kronos, and so on. So then let me say that there is a thread that connects MPEG standards. So in 20 years ago, we had MPEG 7, which was a collection of standard audiovisual and multimedia descriptors. Then we had the compact descriptor for visual search. That's about mid-2010s. And then we had the compact descriptor for video analysis. Now we are working for video coding for machines. So we have descriptors that allow a machine to get the information. And then we have MPEG IoT, the architecture and API to search and communicate between IO and THEES. So these are some definition for Internet of Media Things. I will skip them, and I will go to this model. So you have an object, something physical, and you can sense and you can act on that object. And what does that is an M thing, where M things means media thing, where you have the sensor actuator processing, and you have commands that can be sent to other devices. So these are, let me skip this. This is how you can combine different Internet of Media Things to build systems. And let me conclude with this this Chinese sentence that I found on the plane from Shenzhen to here. So it says, 有子曰理者用和为贵. But I need some interpretation. So Li, of course I know that Li is completely different from what I have in mind, but for me Lean is to classify and to organize how you do things. And that is, to me, corresponds to standards. So you use the standards, and if you have peace, you can do great things. So in MPEG, we do standards. We don't have much peace, so I don't guarantee for the future. But let me say just two conclusions, that the video and audio everywhere became possible with MPEG audiovisual compression standard. I repeat what I said for MPEG 2 25 years ago. Artificial intelligence everywhere will become possible with MPEG neural network compression standard. And you can rely on MPEG, setting aside the Chinese saying that I said before. Thank you for your attention.
That took under 3 seconds, about 2.5 seconds. So think about that. 67 seconds in 1950 to under 3 seconds in 2013. Last year, the record was broken once more. The fastest pit stop now is under 2 seconds. So what are some of the differences? Give me some of the differences, other than the time. Why? What enabled the time to be so much faster? Teamwork. Teamwork. Number of people, right? So those are the two things that I really want to talk about for ZenLayer and what we're going to do next. And I really want every one of you to ask yourselves, in 1950, no matter how many people you said would work on that pit stop, do you think anybody thought it was possible to do a pit stop in 2.5 seconds? So the differences: teamwork, working together. What we are going to do next, what ZenLayer is going to do next, is no different than what we just saw. Up until this point, we've had extremely capable individuals, the people in this room, who have worn multiple hats and have tried to do as many things as they can to get ZenLayer to where it is today. ZenLayer would not be here without those individuals. But as we move on to the next step, the next phase, we're going to be adding more people. But simply adding more people is not sufficient. That is not enough for ZenLayer to succeed. We have to work together. In that 2013 pit stop, if one person had messed up and hadn't done their job, the entire time would have been messed up. The entire pit stop would not have gone off as flawlessly executed as it did. So what we have to remember is, as we move forward, we have to work together as a team. And a lot of what I'm going to talk about, the groups that are working with me, it's not just about those groups working in isolation. It's about how do we all work together. So the way we're going to accelerate towards our goals, the goals that Joe talked about just before: $1 billion of US revenue, 2,000 plus employees, and being the #1 edge cloud provider in the world. The only way we get there is by working together and remembering that we need to be one unit, no matter how many people we have. So, before I go any further, I wanted to take an opportunity to introduce myself. My name is Nikhil. I joined just under 1 month ago. This is my family. I have a wife, I have a dog, I have a baby girl, and as of 1 month ago, ZenLayer is also a part of my family. Why did Joe and Ellen invite me to be a part of this family? Well, I've raised a lot of money. I've raised over $8 billion during my career to support over $5 billion of acquisitions. A lot of what we're going to be doing in the coming months, years, decades is going to require us to be able to raise money and to make acquisitions. I've worked for public and private companies in the United States and large companies, but the thing that I'm most proud of are teams and process, the teams that I've led and the processes that we've implemented. As ZenLayer grows, as we grow, as I said before, and the theme that we're going to cover throughout, we can't just have lots of people and throw lots of people at the issues that we're going to face. We have to work together. We have to establish processes as we turn into a much larger company so that we're doing things in a disciplined way and we know that we can achieve the goals we set out to achieve. So why am I here? I'm here because I believe in the ZenLayer vision and mission. I think improving the digital experience for every person in this world is achievable for ZenLayer. ZenLayer has the potential to impact and to change the lives of every single human on this planet. And I want to work with all of you to do that, for us to do that together. So let me introduce you to the Office of the CFO and the groups that are in this office. We're going to have FP&A, which I'll talk about, accounting and internal controls, treasury, corporate finance, tax, M&A, and legal affairs. So how are we going to accelerate in 2020? I can isolate this and distill this into 3 buckets: performance enhancement, capital raising, and growth. FP&A is the first group that I want to talk about, and this is squarely in the performance enhancement bucket. We're going to implement processes and create the tools that allow us to better budget, forecast, and then after we've budgeted and forecasted, understand why our actual results aren't the same as what we thought they would be. The only way that we are going to get better at predicting our own abilities is to understand why our actual results have differed from what we thought we were going to do. The only way we're going to inspire the confidence of investors is by giving them a forecast and telling them that our variances are minimal in the past based on our history. So we're going to spend a lot of time working on that. FP&A is going to be leading that charge, but we need all of your help. As I've said from the outset, it's about teamwork. And we're going to be reaching out to each and every group to figure out how we can better predict and then reconcile the differences that we see from our budgets and forecasts to our actual results. The second bucket that FP&A is going to be spearheading is project support. So let me give you an example of this. Let's assume that we have a project. We need to put up 300 servers in Rio de Janeiro. We have 1 year of contractual revenue associated with that project of $2.5 million, and the equipment is going to cost us $2.4 million. So, what's our thought process around that? How should we evaluate this? Right now, we know, okay, Brazil is a market that we should enter. It's profitable. Great. On the face, the numbers here, it doesn't look like we're going to lose money. Maybe we should do it. Does this revenue actually lead to more revenue for ZenLayer? Hopefully. Now, that's all intuition. There's some numbers associated with it, but a lot of it is intuition-based. As we grow, that is not going to be sufficient for us to make the best decisions possible. I would say that process right now is called the gut check. The gut check is important. We have to pass a gut check, but we can't simply rely on a gut check. In the future, what are we going to do? We're going to ask all the same questions, but we're going to create a standardized process, a standard template that we can evaluate projects across to understand not only whether this on its own is a good project, but is it the best use of the fixed resources that we have? Are we better served applying our funds here, applying our precious capital on this project, or are there 4 other projects that are more deserving because their return profile is higher? Again, this is not something that we're going to be able to do in isolation. We're going to have to work with every one of you to come up with the right information, to assign the probabilities to different outcomes so that we know that at that point in time, we are making the best decision we possibly can with the information that we have. Accounting and internal controls. Capital raising is going to be one of the biggest things that we do, but it's going to be through this. We are going to conduct a US GAAP audit. Now, what does that mean? GAAP stands for Generally Accepted Accounting Principles. And every company, just about every company that goes public in the United States, has to have a US GAAP audit. The reason I'm calling this out to this group and telling you that we're going to embark on this project is because, once again, it's going to require all of us to work together. Accounting is going to come and ask all of you questions for things that our auditors require. And I want you all to understand that if we ultimately want to be a public company, this is something that we cannot avoid, that we need to do. And so when accounting comes and knocks on your door, please answer. Performance enhancement is another place. Right now, we have a very distributed set of systems that aren't necessarily integrated and that don't communicate with one another. They're siloed. What accounting is going to do, along with internal controls, is spearhead the process to determine how we put all of our systems together. How do we put a CRM in place? How do we get that integrated with OSS? How does that integrate with our accounting system? How does that integrate with a contract management solution? All of those are questions that accounting and internal controls need to be a part of, because eventually, as a public company, all of that interconnectedness will be scrutinized by our auditors. Once again, this cannot be done in isolation. We have to work together. So look out for that, please, in 2020. In Treasury and Corporate Finance, performance enhancement, we're going to look to improve our working capital. So what is working capital? In a nutshell, working capital is when are we spending money, actually giving people cash, versus when we take our cash in, when we collect it. And we're going to try to get better at that so that we aren't sending cash out without bringing cash in. On the capital raising front, we've talked about this a little bit. Joe mentioned this earlier. We're going to raise a Series C. Now, up until this point, we have had incredible partners, some of whom are in the room with us today. As we move on, as we take the next step as a company, as we embark on becoming more of a global company, we're going to look for a different type of investor that can help the already strong investor base that we have. And that means a US and global anchor investor, so that as Zenlayer grows, as the name brand grows, so does our profile among investors. So this is one of the most important things that corporate finance will be doing, and we hope that by Q3 we've closed our Series C funding, which will enable us to grow, namely for us to continue our investment in the bare metal cloud platform. And of course, we've talked about it a few times now, but we're going to be preparing to eventually IPO. Lastly, what that says is find the best sources for project financing. Right now, the way that we finance our projects is with equity. Equity is the most expensive form of capital that we have. It's the most precious form of capital. So we're going to look at other options. We're going to look at debt. We're going to look at leasing to find the most effective and efficient way for us to finance our growth. M&A, growth. We are going to evaluate acquisition opportunities. So what does that mean? Joe talked about the company that we're going to be in the future. We're going to have 2,000 employees, 1,000 employees in R&D. Even so, there are going to be capabilities that it's better for us to go out and purchase rather than organically create. So we're going to continue to evaluate acquisition opportunities, just like Microsoft, just like Apple, just like Amazon. All of these companies that still continue to go out and acquire when they find that somebody else's capability can very, very well integrate into their own capabilities. A key here is all of you. You all know who the best and the brightest are outside of this room as well. And to the extent you find something that you think is a very, very good fit that Zenlayer should be looking at, I welcome you to come and tell me. Lastly, legal affairs. Legal affairs gets a bad rap, right? They get a bad rap. Lawyers get a bad rap. But I want to emphasize that they are a part of all three of these. And during this year, legal is going to be a partner, going to become more of a partner to the entire business. On the performance enhancement side, there are a lot of processes that legal has right now, Number one among those is the contract review process. We're going to overhaul that. We're going to try to make that more efficient. And once again, we're going to need your help to do that. We're going to implement a contract management system, which I've talked about. And then on the capital raising and growth side, legal has the monumental task of supporting finance, tax, and M&A. So everybody, please, when the lawyers are coming and asking questions, it's in the best interest of this company. So, what does all of this add up to? What does this new structure, new departments, plus these 3 buckets of performance enhancement, capital raising, growth, plus ZenLayer, what does it all add up to? What it adds up to? Let's accelerate. Let's do it together.